mixed numbers this time. When it comes to mixed numbers, I actually like to stack them on top of each other so I can see the whole number in the fraction column. So I'm going to say 3 and 4/9 plus, notice that I'm putting my 1 in the whole number column, 1, and then the fraction goes in the fraction column, 5/6. Excellent. Top bid. What's a common denominator for 9 and 6? Multiples of 9 until you get one. 6 works. 9, 18. Yes, you want to go with the smallest one so you don't have to do a lot of reducing at the end. If I pick 54, that means I'm going to reduce at the end, which is fine. Nothing wrong with that, Asher. Just depends on whether or not you like to do all that work. Notice how I've got my fraction bars lined up next to each other. I've left space so that I can do a little bit of number crunching. Like 9 times what was 18? So if I do 9 times 2 like this, it reminds me that I need to do the same thing in my numerator. 4 times 2, 8. And then 6 times what was 18? Times 3. So I'm going to do it in the numerator as well because it reminds me that I need to make sure I adjust both my numerator and my denominator by the same number. 5 times 3 is 15. All right. I'm ready to add up my fractions. Here we go. 8/18 plus 15/18. Well, I already know it already has that common denominator that I worked so hard to get. Then I just need to add 8 plus 15. 15 plus a 5, and then however many are left over. 23. Am I done the problem? No. I do have 3 plus 1 to do. Am I completely done this problem? We have a whole number that's in the improper fraction. Now that we have mixed numbers, we do need to get that whole number out of there. How many times can 18 go into 23? Once. And there's 5 out of 18 left over. So 18 goes into 23 once, and then 18, 19, 20, 21, 22, 23. There's 5 pieces still left over. And what I need to do is I need to add the whole number to that. Change it to a mixed number so that you can see the whole number that's in there, and then finish adding your whole numbers together now. 4 plus the 1 I just pulled out is 5 and 5/18. So now we do need to make sure that we're changing our improper fractions to mixed numbers if there's a whole number to combine with it. Does order matter when I'm setting these up? Yes. It does matter, especially on subtracting, because 4 minus 5 is not the same thing as 5 minus 4. That is different with subtracting. So you got to make sure that you hold the order. This is my first number, so I write this down first. 3 and 4/9 minus 1 and 5/6. Again, I want to find that common denominator. For 6 and 9, we know it's 18 again. And then adjust your numerators. 9 times 2, so 4 times 2 is 8. 6 times 3, so 5 times 3 is 15. This time we're subtracting. Yep. What do you think about this? It's the same problem, but we're subtracting. Can I subtract? Can I do 8 minus 15? No. What do we always do on a regular subtracting problem? What would we do if we couldn't subtract on just regular numbers, whole numbers? You would borrow, wouldn't you, on a regular subtracting problem? So where am I going to borrow from here so I have enough? So I'm going to borrow how much from the 3? Just 1, so that leaves a 2 there. What do I do with the 1? I'm going to put it in front of this number, and then I'm just going to change that to an improper fraction. I took the 1 and I put it with the fraction part. Now I'm going to change this to an improper fraction. You multiply and then add to change it to an improper fraction. 18 times 1 is 18 plus 8. Now you multiply and then you add. So 18 plus 8, 2 for 20, and there's 6 more, so that would be 26/18. Can I do 26/18 minus 15/18 now? Yes, I can. 15 to 25 is 10. So 15 to 26 would be 11/18. And then 2 minus 1 is 1. And I'm going to write the word here, borrow. Borrow. That way, if you ever have to look back to a borrowing problem, you'll be able to find how did you borrow. All right, let's look at the other two papers that are about improper fractions and proper mixed numbers. Really, these papers should have come before the foldable. Next time. Let's look at this. Draw a number line with 2 7s and 6 7s on it. Is 2 7s greater than 1 or less than 1? How about 6 7s? Is 6 7s greater than 1 or less than 1? They're both less than 1. They're not improper. If they were improper, then I would know they're more than 1. So we're at 0, and I need to have how many pieces? Between 0 and 1, how many pieces do I want to break it up into? How many pieces do I need? I need 7. It's in 7s, right? It's in 7s. So 1 7, 2 7s, 3 7s, 4 7s, 5 7s, 6 7s, and 7 7s. 7 7s. How much is 7 7s? What's 7 7s? Why did I stop at 7 7s and I didn't go 8 7s, 9 7s, 10 7s? It's 1. That's right. It's 1 whole 1. I'm going between 0 and 1, so I just counted until I got to 7 7s. Now I need to identify 2 7s and 6 7s. 1 7, 2 7s, 3 7s, 4 7s, 5 7s, 6 7s. I've identified on the number line where those two fractions are. And I will be counting places. If you're off a little bit as far as the spacing on them, I'm not really looking at spacing, but I am looking for the accurate number of lines that are in there between 0 and 1. How many places do I have? 1 7, 2 7s, 3 7s, 4 7s, 5 7s, 6 7s, and 7 7s. I'll be looking for that. Not necessarily that they're all evenly spaced out. They got to be close. I mean, you can't have it very far away and then have a little tiny thing. That's obviously off, right? Deacon, what's B? Mix. And Nathan, the last one. Roper. All right, use it. How do I change a mixed number to an improper fraction? So go like this. Put multiply. Draw an arrow going from 9 to 3 is multiply. And after I multiply, I'm going to take and go to 4, and I'm going to add that in. So you multiply, and then you add, and you keep the same denominator. All right, so 9 times 3 is 27 plus 4, 31, and then you keep the same denominator, 31 ninths. We'll be doing a lot of improper fractions when we're multiplying and dividing. You can't multiply and divide mixed numbers. It has to look just like a fraction only. So that's when you mostly use improper fractions, is for multiplying and dividing. And then to go the opposite direction, what does this say again? It says 23/5, but it says something else as well. What's it say? It says 23 divided by 5. 23 divided by 5. That's what it says. So that is what we're going to do. How many times is 5 going to 23? How many? 4 times, yeah. So 5 goes to 23 4 times. No numbers to bring down. We're not doing decimals. So I'm not going to be adding decimals and adding zeros. I just say it doesn't go into 2. So I'm not going to put the 4 above the 2. It goes into 23. So I put the 4 above the 3. 4 times 5 is 20. When I subtract, I get 3. If I was doing decimals, I'd add a decimal, I'd add a 0, and I'd bring it down, and I would keep going to know what the decimal was. I just need to write my final answer. How many whole times did 5 go into 23? 4 times. You need to figure out what the fraction part is now. There you go. There's 3 left out of 5. 3/5. There you go. You just divide it out until you have no more numbers, and then you take your remainder and make it a fraction over the dividend. All right. One more sheet to practice on, and then we are done. I just wanted to get into mixed numbers this week and something else that's a little different. We just got out of integers. That doesn't mean we're done integers. You're still going to see them all year long. Show yourself you're multiplying. 1 times 8 was 8, so 2 times 8 is 16. And then 16 eighths minus 13 eighths. 16 eighths minus 13 eighths equals 16 minus 3. 3 eighths. That you knew how to do. I'm curious what you think about number 2. Let's start with our common denominator first. Number 2, what's a common denominator for number 2? 15. Notice I left you enough room on both sides so you can make the fractions right next to it. So 15 is the common denominator. Adjust your numerators. Sort of. So 5 times 3, so 9 times 3 is 27. 3 times 5, so 4 times 5 is 20. I'm going to rewrite this problem now that I found my common denominators because I'm curious what's going on between the fractions. It says a fraction plus a negative fraction. What is a positive times a negative? This equals 1 negative. I just want one sign there. I don't want 2 signs. I always get rid of double signs all the time. A positive times a negative is a negative. So we're looking at 27 fifteenths minus 20 fifteenths. 27 minus 20, that would be 7 fifteenths. Looking at number 3, is there anything that pops out to you right in the beginning? You're like, yep, I'm going to do this. What stands out? Why did he change it both positive and negative? That's right. So right here where it says a negative times a negative, right off the bat, I'm just going to say that that is plus, plus, or I could have made just one big plus sign there. All right, so the double negatives are done. Do we have a common denominator? No, we need to find that common denominator. So, what is the common denominator for 3 and 2? 6. Watch out for this negative that's in front of that 4. It belongs with the 4. 3 times what was 6? 2. So negative 4 times 2. What's negative 4 times 2? I should put it on this side. It would be negative 8 times 2. Negative 4 times 2. You've got to keep that negative with it. I just put the times 2 on the other side so it wasn't near the negative. That's negative 8. And then 2 times what is 6? So 3 times 3 is 9. Now it says negative 8 6 and positive 9 6. It says, don't say anything. Let's think about it for a second. It says negative 8 6 and positive 9 6. Well, I already know that my denominator is going to have a 6 in it. I just got to look at the numerator. What's negative 8 and positive 9? Or I could say 9 minus 8. We're going to get to properties in a future chapter. Negative 8 and positive 9 is still the same thing as 9 minus 8. All right, 1. So you can see where you still have to be thinking about your integer rules. Are they the same sign, different signs? Looking at number 4. Wait, at number 4. Do I have the same sign or different signs on number 4? They're the same sign. So what do we do when it's the same sign? We add them up and when it's the same sign, you add it up and look at your keep the same sign. We're going negative, forget about the fractions for a minute, let's just get a handle on the operation. We're going negative 3 and then we got to continue in the negative direction. That means you got to add them up and keep the same sign. All right, so we know that if we are going to be adding these and it's going to be a negative answer. Do we have a common denominator? We already have a common denominator. How nice. So let's add up 3/5 and 2/5. How much is 3/5 and 2/5? You're adding them up because they're like signs. 3/5 plus 2/5 is 5/5. 3 plus 4 is 7. When they're like signs, we add them up and keep the same sign. I'll stop there so that you can think about it for a second. It's a lot to take in when you have fractions and integers. It's important that you go slow and think about it. Are we done on this answer? That is exactly the same thing. That's what they actually show you in junior high school. I like to take double negatives out, but you can certainly do that. That's how we were doing it in the beginning. That's good. Then you stick to what it is that you like. He's like, I'm going to go like this. -3 and 3/5 plus -4 and 2/5. If that's how you feel more comfortable to see that you are adding two negatives, I don't mind that you do that. Not at all. Yep. And again, whatever works for you. Are we done? Is 5/5 proper, improper? Is 5/5 proper or improper? What do you think, Mark? I hear proper, improper. Mark, what do you think? Is 5/5 proper or improper? Proper? Can 5/5 be reduced? To what? It's not proper then. 5/5 is improper because it can be reduced. Right? 4/5 would be proper, and then 5/5 becomes improper. So 5/5 is 1. This is 1. So, how does that work? I have a negative number and I want to add 1 to it. So I would say -8. Okay, here we go. 2 1/3 plus a negative. So I'm going to line them up on top of each other. 2 1/3. And I'm adding a negative. 1 2/3. So I want my fractions lined up. Actually, I'm not having to find a common denominator on this one either. 2 plus a negative 1. What are we going to do on 2 plus and minus 1? What are we actually doing here overall? Are we adding, subtracting? We are subtracting. We need to subtract. Can I do 1/3 minus 2/3? No. You know, we can do the same thing that we did up here on the other one by borrowing 1. We can do that, right? We can borrow 1 and change it into a improper fraction again. Or we could just change this whole thing into an improper fraction. What do you guys want to do? Borrow 1 or change 2 1/3 to an improper fraction? 2 1/3? Okay, let's change both of them to improper fractions. The only reason I'm doing this is because the numbers are small. If I had big numbers like 15 and 16 out here, I would not be changing it to an improper fraction. I would borrow. But these are really small numbers. Okay, well, how do we change 2 1/3 to an improper fraction? We what and what? We multiply and then we add. 3 times 2 is plus 1. 7/3. And then we'll change this one to an improper fraction. Asher, this one's yours. What do I do? It's 3 plus 2. So we have 5/3. Now can I do 7/3 minus 5/3? 7/3 minus 5/3. 2/3. How do I know if it's going to be a positive or a negative? The larger number, 7/3 is positive, it's larger. That means it's going to be a positive number. Take the sign from the larger number. Okay, one more. 6 and 4/5. Subtracting 5/8. Keep it in the fraction column, even though there's not a whole number there. Find your common denominator. I did what I do. Yes, it is. 2 and 4/5. Okay, find your common denominator. Adjust your numerators. Okay, the common denominator has to end in a 5 or a 0, so I'm going to say 40. Lower than that. 8 times 5, so 5 times 5. 5 times 8, so 4 times 8. All right. We're just going to subtract. 32 40ths minus 25 40ths. Can I do that? I can. So 25, 7 40ths. And then what's the whole number going to be? 2. 2 minus nothing is still 2. 7 40ths is reduced. I don't have to worry about reducing. Okay, we'll take these into our notes.